Alright, so we're going to begin our fourth video in this unit, triangle applications, and this one I kind of get a kick out of. I don't know why, but I think this is one of my favorite lessons to teach. This is over area of triangles. I kind of like it because I feel like this is the point at which I get to tell you that all of your math teachers up to this point have lied to you. And I'm going to teach you something that they've told you for years and years you can't do. So I'm going to tell you in this video, explain how you can find the area of any triangle. So all this time they've been telling you need a base and a height in order to find an area of a triangle. And that you had to have a height that was perpendicular to a base, and then you could find the area. It's still true that if you have a base and a height perpendicular, that you can find the area of that triangle by using the formula that you're used to, 1/2 base times height. Sorry, my pen is giving me some trouble. 1/2 base times height. So in this case, it would be all of this times this. So what I'm going to say instead is that I can use some right triangle knowledge to say, well, if I just know this angle and any other side would be enough to tell me this height. I could use, in this case, let's see, that'd be sine to find that height. And so I can use right triangle trig to say, no longer do I need a base and a height, I just need a side. So if we go back to, remember we did law of cosines, we said if we had SAS. SAS meant you had to have the included angle. So if you know any two sides and that included angle, you can use sine in order to replace that piece of that height information. So the area of this triangle now is 1/2 AB, the two sides, times the sine of C, where B sine C really is this H. It's just using trig to find it. So you're not having to find it every single time. We're shortcutting the formula. So I really think this is kind of neat the way it works out. So I'm giving you a new formula for area of a triangle that works for any triangle without having to have the base and the height. It's going to find the height for you in there rather than you having to find it by dropping in a perpendicular. So any two sides, side, and the included angle, and you can use 1/2 AB sine C. So 1/2 side, sine of the included angle. All right, so let's try to put it to use. So I have a side, and the angle that is between those two sides, it's touching those two sides, is 20 degrees. So I can use the formula to find the area. 1/2 AB, oh my goodness, my pen is really not working today, sine C. So that's going to come out to A equals 1/2. It doesn't matter which order those sides go in, sine of 20. And from here, I just stick that in the calculator. And the calculator tells me that the area is 28.22 centimeters squared. So all of this stuff in brown comes out to 28.22 centimeters squared. Now remember from the other videos, if I had SAS, that also enabled me to use law of cosines to find a missing side. But law of cosines, while it uses the same SAS, is a cosine, while this area of a triangle is a sine. So be careful about that. And because we're going to use this in class next time, I am going to go ahead and remind you of how to find that missing side. Because sometimes we need law of cosines in order to finish that problem. So we stick this whole thing in the calculator. But remember, the number that comes out is nothing. What's important is the square root of that number. So I get 5.99 centimeters. Now I could also find one of the missing sides, or I could use law of sines to find a missing side. I could use cosine or sine, or angle. I said side. I could use law of sines or cosine to find the missing angle. And I think that just to do a little bit of practice of both, I'm going to use law of sines because we're going to put it all together in this last day. So I have C and C now. I have the measure of angle C, which is 20, and the side length C, which is 5.99, provided I didn't mess that up. So I can use that to find the measure of angle B. So angle B over 11, and I'll come back and I can do A another way. So 5.99 times the sine of B equals 11 sine of 20. Divide by 5.99. Let the calculator do the icky work. And remember, there's always that one last step. This is the sine of B, not B, so I do have to take the inverse sine. And the inverse sine of that tells me 38.895 degrees. Now, remember, with sine, there's always two possibilities. You have your other value for B as well. So if I type in 180 minus that, it's going to tell me the other possibility is 1.05 degrees. And so this is one of those where you're going to have to consider your most reasonable answer. If I go with the original B, then A plus B plus C have to add up to 180. B was 38.895 plus C was given at 20. I should be able to find the measure of angle A at 121 degrees. But if I go with the second triangle, and we add up to 180, and B is 141.105, C is still 20, then that's going to give me an A value of 18.895 degrees. So now it comes back to, and remember the point of this, the new stuff is all right here. I'm just kind of reviewing some old stuff, putting it all in at once. If you go back to that idea that solving a triangle means finding all of the bits and parts, all of the angles, all of the sides, 20 degrees was given, 15 centimeters was given, 11 centimeters was given. We were able to find that missing side 5.99 that was given. There was no question about that. It wasn't until we got to B that we started to question. And so we go back to that idea that the longest angle, or the largest angle, has to be opposite the longest side. And since A is the longest side, that's given as the longest side, then angle A has to be the largest angle. So the largest angle here was the 121. So A has to be the 121 and B the 38.895 that went with it. And so there was a little bit of problem solving there at the end in order to figure out which one of those. So really this is a great review in this one example. Now the example was just find area, but then I went ahead and solved it so that we could look at law of cosines and law of sines and how all that fits together and what goes with what. Now again, instead of using law of sines, the better way would have been to use law of cosines because I had all three sides. And that's one reason we have the law of cosines, because it's only going to give you one answer, where the law of sines makes you think you have two, but only one of them is reasonable. Okay, and it gets even better. So not only can you use that formula that I just gave you, area equals 1/2 AB sine C of the included angle, but there's also another formula. So there are actually two ways to find area of a triangle without a base and a height. So two ways that for years they've been telling you couldn't do something. So this is called Heron's formula. And Heron's formula uses the perimeter of a triangle in order to find the area. So you don't need any angles in order to use Heron's formula. Okay, and actually it uses something we call the semi-perimeter, not the perimeter. The semi-perimeter is just half the perimeter though. So it uses the semi-perimeter because you're going to take the perimeter and you're going to divide it by 2. So you don't need any angles. And you can say that if you know all three sides, then you can find the area of the triangle using this, where S is that semi-perimeter. So S, and I think I have it on a slide here. There it is. S is add up all three sides and divide by 2. And you're going to use that number 4 times. So S times s minus the first length times s minus the second length times s minus the third length. And then you're going to take the square root of all of that. So let's look at what this looks like. We're going to try this once. All right, so here we are trying to stain a wood, it looks like a wood deck. It tells us the 3 side lengths and asks us, we have enough, if a gallon covers 400 square feet, how many gallons are we going to need? So I'm going to draw a triangle deck, which I had already put in there, and I'm going to label my sides. And then it's just a matter of using the formula. I like to find my semi-perimeter first. So I like to find the perimeter. 88 plus 65 plus 72. So the semi-perimeter is 1/2 of 225. So for S, I'm just going to use 225 divided by 2. So my big old long formula is going to involve S minus A, S minus B, and S minus C, where A, B, and C are just the side lengths. So it's going to involve 225 over 2 minus 88, 225 over 2 minus 65, and 225 over 2 minus 72. Now what's really nice is if you're using my Inspires at school, you can put this in just like this. And you can see the fractions very neatly, and it's not a lot of confusion about what goes where. So you can type this in as one big old piece. You can even put the square root in there as one big piece. As long as you remember the parts, S, S minus A, S minus B, S minus C, you should be able to see all of this in the calculator at one time. Now if you're doing it at home or if you're doing it on another calculator, these parts get so much harder to see. In fact, I don't have an Inspire at home, I have an 84, and it gets really tricky. Did I put all the pieces in the right spot and divide it by the right thing? So this is the one time a year I actually like my Inspires. Alright, so we type it all in, and it tells me the area is, and I'm going to write it over here I think, the area is 2,302.68 square feet. So the question though was how many gallons of wood. If a gallon covers 400 square feet, then I'm going to get 5 point something. Let's put that in the calculator, 5.75. Well, since I can't, or actually 76, since I can't get 0.76 of a gallon, we're going to have to buy 6 gallons of stain in order to cover that triangular deck. So a little bit of problem solving there at the end, and then a little bit of practice using that new formula, Heron's formula, for if we don't have an angle and we just have side, side, side. Alright, we're going to do another example, only this time I got a little trick in store for you, because when we look at this one and I ask you to find the area, you notice you have neither SAS, for which you can use area equals 1/2 AB sine C. You don't have SSS, where you can use Heron's formula, which is that big old long S, S minus A, S minus B, S minus C, square root of all that. And so in order to do this, in order to use either of those formulas, you need 2 sides. Now, if you could get an included angle, you only need 2. If you can't get the included angle, then you need 3. So I think if I were careful, I've got this angle and this side. So if I could find this side, I would have enough to use this. Okay, so in order to find this side, I have to think, will either law of cosines, which is the easy one, there's no ambiguous case, or law of sines, which sometimes has the ambiguous case, be enough information to find that missing side. So law of cosines, remember, we needed SSS or SSS, both of which, if I had, I could use area of a triangle. So it looks like if I have enough information for law of cosines, I have enough information for area, which means if I'm missing information for area, I'm going to have to resort to law of sines. So law of sines is sine of an angle over its side, opposite, over sine of an angle over the side opposite, over the sine of an angle over the side opposite. And so in order to use this, remember we needed one pair of opposites. So do I have a pair of opposites? And it looks like I do. And then really I don't need the 115 because I'm not looking for that side, but I do need this angle. Well, if I have two of the angles, 48 plus 115 plus, I'm going to call that for M, for missing, then I really have the third because I know they all add up to 180. So I could just say 180 minus 48 minus 115 and say that that M has a measure of 17 degrees. So I'm going to go ahead and set up the ratio I have, which was the sine of 48 over 11 centimeters equals, the piece I'm looking for is with this opposite the 17. So x sine of 48 equals 11 times the sine of 17. I divide by the sine of 48 because it's just a number. And I find out that x is 4.328 centimeters. Now x was only one piece of the triangle, right? That was only one side of this triangle. That's this piece. But that gave me enough information to then use the SAS formula, the first one, which came from 1/2 base times height. It's just using B sine C as the height. So 1/2 one leg times the other leg times the included angle. Type that in the calculator and we have the area, which in this case is 21.53, that's not a 3, centimeters squared. But we did have to use law of sines in order to find one of the missing sides to get there. Now I also could have used it again, or I could have switched to law of cosines to find this third missing side, and then I could have used the other formula. So if you want to, you only really need one of these formulas. You could use law of sines or cosines in order for you to get to the other formula. So just keep that in mind. There's a little bit of decision making to be done in each one of these. Alright, and that's it. This video I think is a little bit shorter, but there's some really good information, particularly in that first example, some good review stuff in there as well. Now this first try these has thrown people off for years, so I went ahead and included a video or a picture of a parallelogram. So make sure if you struggle with what goes where that you look at the picture and you think about what it means to be a parallelogram and the diagonals bisect each other of a parallelogram. So make sure you give these a shot, put them into the summary as well as write your summary, and I'll see you in class. We're going to do some board races tomorrow in class, I think, so we're going to have a little bit of fun with some of these problems. We'll see you there.